Okay, we're going to take a look at several problems in Quiz 1 for Section 6-3, Applications of the Normal Distribution. And the first problem says the average length of crocodiles in a swamp is 12.5 feet. If the lengths are normally distributed with a standard deviation of 2.1, find the probability that a crocodile is more than 12 feet long. Okay, so when I look at this, we're interested in the probability x is greater than 12. All right, and in this unit between chapters 5 and 6, we're interested in probability distributions. So we have to ask ourselves, what type of distribution does this thing have? And it tells us that they are normally distributed. Okay, so if that's the case, I know what to do. I need to convert my x value to a z-score. And so we'll do that by saying z equals x minus x bar over s, or 12 minus the average length is 12.5, and my standard deviation is 2.1. Okay, when I do that on my calculator, I get negative 2.4. We're going to round our z-scores to 2 decimal places. That's negative 0.24. Okay. So from there, I'll use my calculator. And we're going to use normal CDF. On the calculator, I'm going to put in normal CDF. So I'll do second distribution. Number 2 is normal CDF. Put in the probability that z is greater than negative 0.24. Okay, if I need to, I can draw that picture. Negative 0.24 might be over here. I want to be greater than that, so negative 0.24 is going to be my lower bound, and my upper bound is going to be infinity. So I'll just put in a very large number. Okay, and so we get 0.5948 as our answer. Okay. All right, in number 2, it says Mrs. Smith's reading class can read a mean of 175 words per minute with a standard deviation of 20 words per minute. The top 3% of the class is to receive a special award. What is the minimum number of words per minute a student would have to read in order to get the award? Okay, so this problem's a little different from the last. If we go back and look at the last problem, you note that we were given x value, we converted that x value to a z-score, and then we used our z-score to find the area or the probability or the percentage. Okay, all right, but in this question, we are actually being given the percentage. And what they want us to find is the minimum number of words. They want us to take this back to an value. So this time we're given a percentage. We're going to convert that to a z-score and then convert it to an x value using x equals x bar plus z times s. Okay, so now I'm going to draw a picture. I'm going to do that first, and we're talking about the top 3%. When we think about the top, we think about high numbers, but we do have to ask ourselves what we have to think about what this particular application is, because in some cases higher is not always better. So in this case, if you have a higher words per minute, then that would put you ahead of the rest of the class. So we will mark off the top 3% as being over here on the right. But while we're talking about this, let's just think about an example where you might be looking at times to complete a race. Well, it's not the higher times that are the better, it's the lower ones. So if we wanted the top 3% of people who ran the race, we would put those 3% over here on the lower end, because lower times are better. So you do need to think about what the variable represents and to decide where that top is going to be. In most cases, the top is going to be on your right, but there are some cases where it'll be on the left, and you just need to look at the particular problem and what the variable represents to figure that out. However, problem, it is on the right. We've got 3% being our top scoring students. The area to the left is 0.97, and we need to know that because the calculator requires to inverse norm. For inverse norm, it requires us to give it the area that's to the left. So I'm going to do inverse norm. So second, vars, number 3 is inverse norm. The area to the left is 0.97. And so we get a score of 1.88. All right, so z equals 1.88. So x equals x bar, which was 175, plus z, 1.88, times my standard deviation, which is 20 words. Okay, and so we would punch that up in the calculator, and that would give us our answer. All right, here's another example. The average hourly wage of workers at a fast food restaurant is $6.50 per hour with a standard deviation of 45 cents. Assume that the distribution is normally distributed. Okay, so that should give you an idea about what to do. Anytime we know that something's normally distributed, our first question should be, what is the mean? What's the standard deviation? Okay, if a worker at this fast food restaurant is selected at random, what is the probability that the worker earns more than $6.75? So what we're looking for here is the probability that x is greater than 6.75. And so we already know it's normally distributed. I'm going to convert this thing to a z-score. So we get z equals 6.75 minus 6.5 over 0.45. So if we do that on our calculator, we get, we'll just call that 5.6. So we're interested in the probability that z is 0.56. Okay, if we want to draw a picture, 0.56 would be over here. We want to be greater than, so again, my lower bound 6, my upper bound is going to be some large number. So we'll do second distribution. Number 2 is normal CDF, and we go from 0.56 to infinity, and we get 0.2877. Or 28.77%. Crime rates per 100,000 residents for the 50 states and the District of Columbia have a mean of 3,377.2 and a standard deviation of 847.4. Assuming the distribution of property crime rates is normal, what percentage of the states has property crime rates between 2,360 and 4,055? All right, so we're looking for, in this case, the percentage and range of values, not just one value, but a range of values to look at. So we're interested in the probability that 2,360 is less than X is less than 4,055. Okay? So I'm going to have to convert each of these to a z-score. So for 2,360, we get 2,360 minus 3,377.2 over 847.4. Okay. So 2,360 minus 3,377.2. Okay, divided by 847.4. And I get negative 1.20. If I change that 2,360 to 4,055, I get 0.80. Okay, so we're talking about the probability that Z is between negative 1.20 and 0.80. Okay, and so I can use normal CDF on my calculator to find that. We'll do second distribution. Number 2 is normal CDF. My lower bound is negative 1.2. My upper bound is 0.8. And so we get 0.6731. Or the closest answer, well, no, there's a 0.67, so I would choose 0.67. Okay, let's take a look at this example, question 5. It says the percent of the voting age population that is registered to vote for the 50 states and the District of Columbia has a mean of 65% with a standard deviation of 7.1. Assuming that the distribution is normal, what percentage of states had between 50 and 70% of its voting age population who are registered to vote? Okay, so first of all, focusing on what the question's asking me to find, it's what percentage of the states had between 50 and 70% of the voting age population who were registered to vote. So I'm going to go ahead and write that down. So probability that 50 is less than X is less than 70. They tell me that the distribution is normal, So again, I need to find the z-score for 50 and also for 70. So z equals 50 minus my mean of 65. Okay, and notice that this is 50% and 70%. So all of these things are in percents. We could either do them all as whole numbers, the way that I'm doing, or do them all as decimals. But the z-score would come out to be the same either way. Okay, so 50 minus 65, and I'm going to divide that by 7.1%. Okay, and then also we will do 70 minus 65 divided by 7.1. I got 50 minus 65 divided by 7.1. Okay, I get negative 2.11, and if I do this again, just going to change that 50 to 70. I got 0.704. So we're going to look at z-scores from negative 2.11 to 0.70. We'll go to our calculator and use normal CDF. So second vars, number 2 is normal CDF. My lower bound is negative 2.11. My upper bound is 0.7. And so we get 0.7406. Or C. Okay, we're going to take a look at one more question from this quiz. And this is going to be one of the ones where we kind of turn it around. Okay, so here it says, suppose a brewery has a filling machine that fills 12-ounce bottles of beer. It is known that the amount of beer poured by this filling machine follows a normal distribution with a mean of 12.47 ounces and a standard deviation of 0.04 ounce. The company is interested in reducing the amount of extra beer that is poured into the 12-ounce bottles. The company is seeking to identify the highest 1.5% of the fill amounts poured by this machine. For what fill amount are they searching? So notice that this question asks us not for a percentage, but it asks us for an X value. X in this case represents the volume that's in the bottle when they fill it. So we want to get the highest 1.5% of those bottles or volumes. So I'm going to put 0.015 over here. Okay, that's my area. Okay, and since we're talking about volume, X equals volume, higher volumes would be on the right. Okay, so we've got 0.015. I need to figure out the z value that separates this upper 1.5% from everything else. Okay, everything else is going to be 1 minus 0.015 or 0.985. And so we want to do inverse norm. That's number 3. And my area to the left of the z that I want to find is 0.985. So we got 2.1. Okay. So if that's my z value, I can find x by saying x bar plus z times s. Okay, x bar in this case was 12.7 ounces. Or 4. Okay, we just found z to be 2.17 and our standard deviation is 0.04 ounce. So when I do that on my calculator, I get 12.5568 or 557. Let's take a look at a few problems from the quiz on the normal approximation of the binomial distribution. The first question says, if a baseball player's batting average is .340 or 34%, find the probability that the player will have a bad season and only score at most 60 hits and 200 times at bat. Okay, so first thing we need to ask ourselves is, what type of distribution does this have? And if we go through the requirements of the binomial distribution, we'll see that this actually meets the criteria for the binomial distribution. We have a fixed number of trials, which would be the 200 times at bat. Okay, we've got two outcomes. He either hits the ball or he doesn't. Probability of success is the same for each trial, and the trials are independent. So it's all the criteria. So what they're asking us to find is the probability that he scores at most 60 hits. Now it's going to be really important that we interpret this correctly. What do we mean when we say at most? Well, that means X has to be less than or equal to 60. The binomial distribution is a discrete distribution, and whether we say less than or equal to will make a large difference. So you really got to read carefully and interpret those words like at most, at least, no more than, less than, however it is it's described. You've got to interpret that carefully. Okay, but if we're talking about less than or equal to 60, before we had fancy calculators, then we had to do a whole bunch of number crunching to get this answer. Or we could use this approximation method. If you look back in the course notes, you'll see an illustration of a binomial distribution, and you can see that it meets the criteria, or it looks like it's approximately normally distributed. So once we found that out, we were able to use the normal distribution to make the approximation. However, we have to account for the fact that we are going from a discrete distribution to a continuous distribution. And the first thing we have to do is find out, how are we going to represent the number 60 in our continuous distribution? So we would carve out an interval, go a half unit down, a half unit up, and this would be in our continuous distribution, the interval that's going to represent 60. Okay, so when I write it, we're going to talk about the probability that X is less than 60.5. Okay, now I'm preparing for my normal distribution. Over here, binomial. And I chose 60.5 because I need this entire interval to be included so that my 60 is included. If this had said just less than 60, then we would be less than 59.5. I would not want to include this interval. But you can go back and look at the video on that for a little more clarification. Okay, so I'm ready to go on with my normal distribution. I need to know my mean and my standard deviation. Well, the mean of a binomial distribution is n times p, or in this case it's going to be 200 times 0.34 or 68. And the standard deviation is going to be the square root of n times p times q. So the square root of 200 times 0.34. Q is 1 minus p, so in this case 0.66. And if we do that on our calculator, I'm going to take the square root of that. Okay, I got 6.69. Okay. So now I can find my z-score. Z is going to be 60.5 minus my mean of 68 divided by the standard deviation. And I'm putting these dots because, of course, I can't write out all the decimals, but I do intend to use them all when I do my calculation to minimize any round off error. So we get 60.5 minus 68 divided by that standard deviation. I'm just going to say second and this negative key to pop in that previous answer, and I get 9.04. And so we get, if we're looking at the probability that z is less than 9.04, okay, I would use my calculator. To go from normal CDF, we want to be less than 9.4, so we'll use minus infinity to positive 9.04 and enter. And we get 1, and that's wrong. Okay.